Welcome to the homework solutions video for assignment 6.01. So these are questions 1 to 4 from pages 14 to 18 in our textbook. So in the first one, Imelda has drawn herself a Venn diagram. So she's got these sections. So this one has apples and pears, which she calls set S. Set F has oranges, pineapples, and bananas. And this set down here, V, has peas, carrots, corn, beans, and potatoes. And she's calling the universal set C. So in her set, C is the set of produce. So F is the set of fruit. So V is the set of all vegetables. And S is fruit that you can eat without peeling. I'm just going to write fruit you don't peel so it all fits on the screen here. So, do we agree with her descriptions? Yeah, apples and pears, we are much less likely to peel than oranges, pineapples, and bananas. So these are vegetables: peas, corn, carrots, beans, potatoes. So I agree. We could ask for another way that she could define her sets in her diagram. You could draw this set as, instead of having a set S, we have another set, maybe P with the ones you do peel. There's a few options. Now see, why does it make sense that S is a subset of F and S is a subset of C? Well, S is a subset of F because every member or every element in the set S is also in the set F, and every element in the set S is also in the universal set C. That includes everything. Part D lists the disjoint sets if there are any. V is disjoint with both F and S because there's no overlap, but those are the only disjoint sets. Remember, disjoint sets are those which have an empty intersection. Now, is the complement of F equal to V? Explain. In this case, it is. Remember, the complement of F is everything in our universal set which is not in set F. And because there is nothing outside of F and V, right, we don't have something here like beef, which is neither fruit nor vegetable, doesn't even really belong in the produce, but you don't have anything in that universal set that's not a part of V. Therefore, yes, the complement of F is V. So then using that, we need to find the number of elements of V using the number of elements of F and the number of elements of C. So the number of elements of C is 10. The number of elements of F is 5. And finding V using that, well, that's because we can do that because we're looking for the number of elements in the complement of F, which is the number of elements in the universal set, minus the number of elements in F, and 10 minus 5 is 5. So that's how to find V using F and C. Obviously, it's easier to just count, but we're told we have to use these two numbers. And then the last part is list the elements in the complement of S. That's everything in here that's not in S. So that's oranges, pineapples, bananas, peas, carrots, corn, beans, and potatoes, which normally on your homework we should list out the entire word, not just the first two letters. So question 2, we have to draw a Venn diagram to represent these sets. So we're going to have the universal set, which is all the numbers from 1 to 40. We're going to have multiples of 8, multiples of 4, and multiples of 17. So the only multiples of 17 from 1 to 40 are 17 and 34. So we don't need a big oval for that. S is the multiples of 17. That will contain 17 and 34. Now every multiple of 8 is also a multiple of 4. We have 5 multiples of 8 from 1 to 40 inclusive, and 10 multiples of 4 from 1 to 40 inclusive. So we need two spaces, each big enough to hold 5 numbers. So E is the multiples of 8, and F is the multiples of 4. And now we can enter or fill in all of the numbers. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and just to make it clear, that is a 16, not an 11. 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. Oh, sorry. We already had 34. That's a multiple of 17. 36, 37, 38, 39, and 40 goes here. So part B, list the disjoint sets if there are any. S is disjoint with E and F. Is each statement true or false? Is E a subset of F? Yes, it is. That's true. So, is F a subset of E? No, that is false, because there are elements in F that are not a part of E. E is a subset of F because every element of E is an element of F. Is E a subset of E? Technically, it shouldn't be with this notation, because mathematical notation distinguishes between subset and proper subset. It's almost like less than versus less than or equal to. So with this proper notation, E is not a subset, or E is a subset of itself. With this notation, it's technically not. But that is not notation that the textbook makes particularly clear. Finally, so they're saying, is the complement of F the odd numbers from 1 to 40? It is not, because there are even numbers not included in F. And number 5, in this example, the set of natural numbers from 41 to 50 is the empty set. Yeah, there are no natural numbers from 41 to 50 here. So that wraps up number 2. Number 3, we have another Venn diagram to draw. So we've got fish species in Nunavut and the Northwest Territories. So I'm going to make 2 of these, and they're going to have some overlap. So the left are Nunavut, and the right are the Northwest Territories. So if we go through the lists, walleye are on both. Northern pike are on both. Lake trout are in both. Arctic char are in both. Arctic grayling are in both. Lake whitefish are in both. 3, 4, 5. There's the difference. Inconnu is only in the Northwest Territories. 2, 3, 3, 4. Yes, we have 6 fish in N, 7 in T. And everything in Nunavut is also in the Northwest Territories. So we've illustrated the sets using the Venn diagram. Explain what the following statement means. N is a subset of T because every element of every element of N is also in T. T is not a subset of N because T includes the species of fish N does not. So that's number 3. And then finally, number 4, we are looking at the universal set U in a deck of 52 cards, where the B are the black cards, R are the red. So we are supposed to have this in a Venn diagram. So here's our universal set. So we're going to have red, we're going to have black, and then we're going to have 2 suits within them. So here's our red, here's our black. The red cards have the hearts and the diamonds. The black have the spades and clubs. And then we'd have ace through king in each of these circles. So list all the defined sets that are subsets of B, that's S and C. All defined subsets that are subsets of R, that's H and D. Are sets S and C disjoint? Yes, they are. There are no cards which are both spades and clubs. Suppose you draw 1 card from the deck. Are the events drawing a heart and drawing a diamond mutually exclusive? Yes, there is no overlap in the sets. You cannot draw a card which is both a heart and a diamond. So you cannot have both in a single draw. Which of the following is correct? The number of spades or diamonds is the number of spades plus the number of diamonds. Yes, this is true because there's no overlap. If they had overlap, it would not be true. So if there were 3 that were only S and 3 that were only D and 3 that were both, there'd be 6S and 6D, but there's only 9 that are spades or diamonds, not 6 plus 6 for 12. So that is why, and then the size of the set S, spade or diamond, is 26, because there are 13 cards in each.